Hello friends, welcome to the T.Y.B.Sc distribution theory class. In previous lectures, we have seen that beta distribution of first kind, PDF, mean and variance, Arthur moment, mode, harmonic mean, and some examples of beta distribution of first kind. In today's lecture, we have seen some examples and also find the median of beta distribution of first kind for the particular value of parameters, that is m and n. So first example is let x be a beta random variable of first kind. Means x has a beta distribution of first kind with parameters m is equal to 1 and your n is equal to 2, and our interest to find k such that you have given that your probability of x less than k, which is equal to probability of x greater than k. Okay, this is our interest. We want to find the k such that we have given this condition. Okay, so firstly, what we have given, that we have given x having beta distribution of first kind with parameter m is equal to 1 and n is equal to 2. Okay, so your density function of beta distribution is f of x is equal to 1 upon beta m, which is 1, n is 2, x raised to m minus 1, so that is 1 minus 1, 1 minus x raised to n minus 1, that is here n is equal to 2 minus 1. So where your x is 0 to 1, so that means your density function is 1 upon beta 1 to x raised to 1 minus 1, 1 minus 1 is 0, so x raised to 0 is 1, multiply by 1 minus x raised to 2 minus 1 is 1. So that means we know that the beta m n is equal to gamma m upon gamma n divided by gamma m plus n. Okay, this is the formula for beta function. So here beta 1 comma 2 is equal to gamma 1 gamma 2 divided by gamma 3, and we know that this gamma 1 is nothing but the 0 factorial and which is 1, and this gamma 2 is 1 factorial which is 1 divided by gamma 3, that is 2 factorial, which is 2. So this value is 1 by 2 and this is 1 upon 1 by 2 into 1 minus x. So that means 2 into 1 minus x, where x is lies between 0 to 1. Okay, this is your beta function. Okay, so this is your PDF of beta distribution of first kind with m is equal to 1 and n is equal to 2. Okay, now firstly here we consider the left hand side, that is probability of x less than k. Okay, so that means your x is 0 to k, maximum value is k into f of x dx. So that means this integration is integration of 0 to k, f of x is 2 into 1 minus x dx, which is nothing but 2 is outside the integral sign and this is your 0 to k 1 minus x dx. Okay, so which is nothing but 2 into this integration 0 to k 1 dx minus 0 to k integration over 0 to k x dx. Okay, so this integration is nothing but 2 to this is your x over the range 0 to k minus x square by 2 over the range 0 to k. Okay, so that means 2 into this k minus 0 minus k square by 2 minus 0. Okay, so which is nothing but 2 into k minus k square by 2. Okay, and which is equal to your 2 into twice k minus k square by 2, and now this 2 to get cancelled, so we get this probability is 2k minus k square. Okay, now further we have to consider the right hand side, that is probability of x greater than k. So this probability is integration over k to maximum value of x is 1 f of x dx. Now this is nothing but your integration over k to 1 2 into 1 minus x dx. Now here I have to outside the constant into the integral sign. So 2 into integration or k to 1 minus x dx. Okay, then again if you have to solve this integration, we get this integration 1 dx over the range k to 1 minus integration over k to 1 x dx. Okay, so that is nothing but 2 into x over the range k to 1 minus x square by 2 over the range k to 1. Okay, so that means this 2 into 1 minus k minus 1 minus k square by 2. Okay, so that is nothing but 2 into 2 into 1 minus k minus 1 minus k square divided by 2. Okay, so which is nothing but this 2 to get cancelled. Here we get 2 minus 2k minus 1 plus k square. So that means 1 minus 2k plus k square. Okay, and we have given that your probability of x is less than k is nothing but probability of x is greater than k. So that means your x is less than k is value, this value is here 2k minus k square, and which is equal to 1 minus 2k plus k square. Okay, so that implies that here I have to just this 2k is here positive, this 2k is negative, so I have to just this 2k minus k square plus 2k minus k square, and again minus 1 is here, so this is 0. All these terms into the right hand side, we have taken it into the left hand side. Okay, so what we get, so 2k plus 2k, that is your 4k minus 2k square minus 1, which is equal to 0. Okay, so I have to just multiply minus sign to the equation. We get 2 into k square minus 4k plus 1 equal to 0. Now this is just the quadratic equation, and we have to solve this quadratic equation by the formula minus b plus minus square root of b square minus 4ac divided by twice a. Okay, this by using this formula we have to find out the k. So k is here. What is your, in this case, what is your a? A is, yes, your a is 2. Okay, now b is minus 4 and c is 1. Okay, so if I have to put here, so minus b, here minus 4, so minus minus 4 plus minus plus minus square root of, okay, b square, that means minus 4 square minus 4 into a is your 2 and c is 1 divided by your 2 into a is 2. So what is your so what is the minus into minus 4 is plus 4 plus minus square root of minus 4 square is 16 and this minus 8 divided by 4. Okay, so 4 plus minus this 16 minus 8 is square root of here 8 divided by 4. So that means 4 plus minus this 8, square root of 8 is, you can write it square root of 8 as 2 into square root of 2 divided by 4. So that means what we get, this 1 plus minus square root of 2 upon 2, that is 1 plus minus 1 upon square root of 2. Okay, this is the value of k. So here we get the two values of k. K is 1 plus 1 upon square root of 2, or k is equal to 1 minus 1 upon square root of 2. But here the k must be lies between 0 to 1. Okay, your k must be into the range 0 to 1. So here root 2 is positive quantity, so 1 upon root 2 is something positive quantity which is greater than 0 always, and if you have to add into the 1, so k is greater than 1. So that case this value is not possible, or you can say that this value is abstract value, means which is the outside the range. So this is not possible. So only in this case the k is 1 minus 1 upon root 2. Okay, so this case, in this example, if you have to ask the question, that is find k such that probability of x is less than k, which is equal to probability of x is greater than k. So here if your k is equal to 1 minus 1 upon root 2, then and then this condition is satisfied. So therefore k is, in this example, is 1 minus 1 upon root 2. Okay, or you can say that it is the median, or you can, another way you can solve the median by using the, suppose if I want to, if I have given the x follows beta first kind with parameter 1 and 2, and we want to find the median. If I have asked this question, so I can solve this by the previous example, or we can solve it by the another another method, that is if we have to given this, suppose x, we have given this beta first kind with 1 comma 2. So your density function is, already in the last example I have solved this 2 into 1 minus x, where x is 0 to 1. Okay, this is the given, and here I have to assume that the m is median. Okay, I'll just assume that, whatever you can write any letter or anything for that median. I have to just define m by m for median. So if m is median, then we know that your probability of x is less than m is equal to 1 by 2, and which is also equal to probability of x is greater than m. Okay, so you can consider any of this equation. You can take probability of x is less than m is equal to 1 by 2, or you can consider probability of x is greater than m 1 by 2. So I have just here considered the first probability of x less than m is equal to 1 by 2. You just consider only one equation. You can consider this or this. Any one you have just consider and solve this equation. You get the answer, that is median, from this any one of the equation. Okay, so if I have to consider his So that means this probability is 0 to m f of x is 2 into 1 minus x dx, which is equal to 1 by 2. Okay, so that means 2 is outside the integration sign. So we get integration over 0 to m 1 into dx minus integration over 0 to m x into dx. Okay, and this value is 1 by 2. So what we get is 2 into m minus 0 minus m square by 2 minus 0, and this value is 1 by 2. So again what we get, 2 into twice m minus m square by 2, and this value is 1 by 2. Okay, so if this 2 get cancelled, we get twice m minus m square is equal to 1 by 2. Or you can write this 2 is here denominator, you can take it in the left side, so it is multiply, so that is twice m minus m square, and this 1 again I have taken the left hand side, so minus. So what we get, this equal to 0. So what we get, 4m minus 2m square minus 1 equal to 0, or you can write it as only I would multiply the minus m 1 to both sides, we get this 2m square minus 4m plus 1 equal to 0. Okay, and again this is your quadratic equation, and this quadratic equation I have solved by using the formula minus b plus minus square root of b square minus 4ac divided by twice a. Okay, if I have to put here a is equal to 2, b is equal to minus 4, c is equal to 1, so we get m is equal to 1 plus minus 1 upon square root of 2. So again here your m is lies between 0 to 1, because it is the median of beta distribution of first kind, and if the random variable of the beta distribution of first kind is lies between 0 to 1, so your median must be the lies between the 0 to 1. So if your m is lies between 0 to 1, so your m is equal to 1 plus 1 upon root 2 this m is equal to 1 plus 1 upon root 2 is outside the range, that is your greater than the, this value is greater than 1, so therefore this is not possible. So your m is equal to 1 minus 1 upon root 2, because root 2 is a positive quantity, so 1 upon root 2 is again the positive quantity, which is something value which is greater than 0. So 1 minus this positive value which lies between again 0 to 1, so this is the median. So your median of beta distribution of first kind with parameter m is equal to 1 and n is equal to 2 is 1 minus 1 upon root 2. So remember that the median of beta distribution of first kind with the particular parameter m is equal to 1 and n is equal to 2 is 1 minus 1 upon root 2. Okay, so thank you.